Hey folks, so I wanted to do a tutorial on fabrication of bars for hybrids utilizing Trilor Arch material. And I was going to make it like this really cut and dry, take this and put it there and glue it on this. And I realized this is going to be kind of boring. So I decided to do something different. I decided to do like a face-to-face, well, my face now, your face maybe later, and talk to you a little bit about it. And I'm going to be inserting clips into the video, kind of showing the whole protocol, but at the same time, I'll be talking about it. And so Trilor, it's a fiber reinforced resin material, and it comes usually in either pucks or arches. So pucks you obviously utilize using like CAD/CAM equipment and things like this, and arches are for people like me who'd like to fabricate something right there in their lab without having to utilize any of that stuff. And it works great because all you pretty much need is a handpiece, some cement or acrylic, and titanium cylinders. So it's not a lot of equipment necessary. Does require a little bit of time, does require a little bit of hand skills, but nevertheless, you can create a fiber reinforced resin bar for a temp hybrid. You can create one for a long-term temp. You can even create it for a permanent prosthesis. I mean, depending what you're looking for and what the underlying situation is or the condition of the patient, you can follow pretty much any of those treatment plans, I guess, the word I'm looking for, and get really good results. So first thing first, does this material have limitations? Absolutely. Any material you're going to be using in dentistry is going to have some limitations. If there was a universal material out there, I'd be the first one to buy it. Unfortunately, as close as I'd like to get to universal material and to be able to buy it, I have not found one yet. If you have, please let me know. I'd like to buy some. So what are the things you need to follow with this material? Well, you want it to be at least 3.5 millimeters tall. You want it to be at least 2 millimeters wide. I'm talking about the bar. And you want all the sides of the titanium cylinders to have at least, I think it's 0.8 to 1 millimeter of material all around it. Okay? When it comes to cantilevers for this particular material, you do not want to use it if you have a cantilever longer than 1 centimeter. So these are the limitations that I see with it. What I really like about this particular material is the fact that you can actually bond stuff to it. I've done experiments where I've taken a piece of Trilor Arch, I roughened it up, I've poured up so-called acrylic on it. I got acrylic on it. I can't even talk today. Sorry, guys. And put it in a pressure pot, waited 15-20 minutes, took it out, could not break it apart. Was using my hands, and I just like putting a lot of pressure on things, and I could not break it apart. So to me, that says this is some good stuff, right? Because we deal with titanium, we deal with zirconia, we deal with chromium cobalt. All of those are good materials for particular situations. And this specific one, the Trilor Arch material, is also great material for specific situations. So how do we fabricate this bar? Let's get into it. So first things first. This material comes in 3 different thicknesses. It comes in a 3.5, a 5.5, and a 7.5 millimeter thickness. Now remember, the minimal thickness you want this material to be, the height of it, is 3.5 millimeters. So if you have a case where all of your implants are all on the same level, you can buy a 3.5 millimeter arch because you won't have to be adjusting things. But majority of times, at least for me, when I'm dealing with situations like this, one implant is right here, another one's right here, and I need to adjust things out. So to me, I prefer to buy at least a 5.5 because if it's a little bit thicker, I can always thin it out. But if it's too thin, then I have an issue. Okay. Once you pick out the material you're going to be using, then you kind of look into things and see what's the game plan for fabrication of this bar. Well, in general, I mostly deal with multi-unit abutments when fabricating these kind of restorations. And when I look at my multi-unit, I'd like to see what angle it has. Because if it's angled this way, for example, I need to realize, okay, then the hole here is going to be on closer to this edge, but the bottom portion is going to be closer to that edge. So when I'm leveling out my wax and marking things, I need to kind of make sure I'm within those parameters. Okay, I need to leave enough room for each side, so I will have to adjust it later on, because you will come to a realization when you're fabricating these bars and making these access holes to put the bar on top of the titanium cylinders, is that just placing one hole is not generally going to cut it for you because of the different angulations of the actual abutments. So a lot of times I'll place starter holes just to line things up, and I'll go back in and mark things in there to make sure I kind of know where to start going and drilling around, just so I can fit that bar down. Let's talk a little bit about the actual steps. So first things first, you have your model, you have your temp cylinders, you looked at the angles and everything else. Now you have to mark the position of those cylinders on base plate wax. And the reason you do that is that it makes it easier to transfer those positions onto the arch that you have. And from that point on, you'll start evening things out. So you take a piece of base plate wax. It can be either medium softness, hard softness, as long as it's got some pliability to it. That's all that really matters. If it's not pliable enough, you can always warm it up a little bit. Now, you have a decision to make. Do you want to mark it from the top of the temp cylinders, or do you want to mark it from the bottom, or where the multi-unit analogs are on your model? Me personally, I prefer to mark it on the bottom because I feel like it's going to be a little bit less offset at that angle. Now, will you have to grind those holes later down the line? Absolutely. But at this point, let's just get it marked and see where we're at. Is there a way to get this absolutely perfect? Yes, there is. But it will require you to, at least in my opinion, to use some CAD/CAM technology. What I mean by that, in order for you to perfectly get the angulations of those implants or temp cylinders, whatever you want to call it, in relation to that arch, you're going to have to create some kind of a guide, a drill guide. So in order to do that, you probably want to scan in your model and get the STL file, import it into 3Shape, Exocad, whatever, and then try to create some kind of split with the guide on top of it. I've done it like this for access holes for hybrids before, and I think it can be utilized in a similar manner when it comes to Trilor arches. Have I done it like this? No, I have not, but I think with a little bit of tinkering, it can be done. But for our situation, we're just going to mark everything with wax, and then we're going to take a blade and open up those holes, just so you can better visualize things. Once that is done, you're going to take your wax and you're going to overlay your wax over the arch. And this is the part where you have to be a little careful, because remember, you're not just placing those access holes. You need to kind of account, are these going to be at the top of the arch, where are they going to be at the bottom? Because just because the access hole at the top of the arch is at this point, at the bottom it might be right here, it might be right there. So you need to look at your model, look at your arch, and kind of work with this. You might have to move that wax in a few different spots to make sure you have the right design. And remember, you want to have at least 1 millimeter, well, 0.8 to 1 millimeter of room around that cylinder all the way around. Okay? Now that you have established where you want to place those access holes, or the holes where you're going to be using those titanium cylinders to cement to, right? What I recommend, highly recommend, is to double check your work, because I've been in situations where I've kind of rushed things and I drilled the holes, and next thing I know, I'm like, well, it's too far to this side or too close to this side, and it's just not going to work, and I'm going to have to just grab a whole new arch. So just by double checking things, you're going to be a lot better off. And then go ahead and mark it with some kind of marking instrument, probably a pencil or a permanent marker. And then you can go ahead and at this point, or maybe down the line, go ahead and mark where you want to cut the arch short. Because let's say, for example, you have a smaller mandible and a longer arch, and it's not going to be easy for you to see how things line up when the arch is oversized. So for this particular case, I think I went mark the holes first, cut the holes first, and only then I went back and marked where the arch needed to be shortened to, and I have shortened it down the line. Okay, so at this point, we're ready to go to the bench and start cutting those access holes. You usually start with number 8 carbide. It is an average size, so it creates a nice and even hole all the way around, just so you can have a starting point. And from that point, you're going to end up with some kind of acrylic burr. I generally try to go small and then just open up to whatever size I need, just so I can fit every single titanium cylinder into those holes. Do I get it right from the start to the point where I need to? No. I generally just kind of try to get it to the minimum, just so I can get things on the model. And then I start to go in and double check everything. Because remember, you're generally not going to have your implants going straight up and down. Usually there's some kind of deviation of those cylinders on top of that model. So you're going to have to look at things, you're going to have to mark things. I'll usually put one in, probably the one that's the most deviated. I'll put that in, and I'll put the bar on top of it, or the arch, whatever you want to call it, right on top of it. And then I kind of look what the angle is. If it's too sharp, I kind of see where it's catching up. And I'll take my pencil and I'll mark that area. Once that is marked, I'll go and I'll start cutting again, opening up that region. And I'll just go from each implant down the line. At a certain point, though, you're going to have to start cutting down those titanium cylinders to the shorter size, because what happens is that if they're too long, it will actually prevent you from sitting that arch on top of those titanium cylinders. So getting them cut down short works fairly well. What I utilize for that is actually a modified pair of hemostats that I've modified to nicely grab either analogs or titanium cylinders, pretty much everything associated with those things, and a diamond disc, just cutting them down to size. At times, I tend to go back a few times just to get it down, cut more, because I don't get the angle right or they're too long. Things like that happen. But nevertheless, I get them down to size. Okay, now that you've got the cylinders cut down to size and the holes opened up to the proper dimensions, you should be able to take your arch and to fit it right on top of those cylinders. Now, those cylinders, you want to have them a little loose, so make sure the screws are not tightened all the way. About halfway down is what I recommend, just to make sure that you can rotate them easily and maybe angle them just slightly, just so you can get that arch on there. Will you be able to do that every single time? Well, no, probably not. You just have to prepare yourself to maybe you're going to have to do 2 at a time or maybe 3 at a time when you do this. In this case, I was able to get all 4 of them down. Now, once you get everything lined up, make sure to tighten those cylinders down to make sure there's no interferences when you do that. Once all of that is complete, double check your work, make sure everything's looking good, and then take your pencil and draw a rough outline of where you want your bar to be. Remember, we're looking for several parameters. You want your bar to be at least 3.5 millimeters high, you want it to be at least 2 millimeters wide, and you want it to have at least from 0.8 to 1 millimeter of material around each of those titanium cylinders. Once you have those parameters established and you have everything drawn out, you can go ahead with burrs and start shaping your bar. Now, I generally start with a lathe and just kind of grind things to a rough dimensions, and then I start going with burrs. Sometimes smaller, sometimes larger. Whatever feels good on my hand at the time is what I'm going to use until I get it to the shape where I feel like this is about an approximation of where I want to be. Once that is done, I will smooth it out using different things, sometimes acrylic burrs, sometimes using Scotch Brite wheels, whatever is feeling like it's going to work at that time. I wish I could have like a more definitive system for you, but it's just pretty much anything works on this. It's just, do you want to go fast or do you want to go slower? That's pretty much the only things that limit me. If I feel like I'm going to overcut things in this area, I'm going to slow down and maybe switch to a smaller size or a smaller grit, something that's going to not ruin my work for me. Okay. Once you have established everything in the area, you make sure and check everything again. Make sure you have enough room. Make sure everything's fitting with this, with the titanium cylinders being loose and with the titanium cylinders being tied down. And at that point, you're ready to prepare for your cementation. Now, for the cementation part, you want to make sure and get the titanium cylinders sandblasted just so things grab a little bit better. I usually utilize a little bit of heat shrink tubing on one side and a piece of Q-tip, just the handle from the Q-tip, cut down, put on the other side, and get things sandblasted, just so things grab better. Now, there's a couple of ways you can attach that cylinder to the bar or that bar to that cylinder. I know of two, probably more than that. But the two main ones is either using like a dual cure cement, is what I use, or just simply using cold cure acrylic. Now, which one is better? Honestly, I don't know. The only reason I use dual cure cement is because I was kind of taught that way and it worked for me, so I kind of stuck with it. I know quite a few people that actually use cold cure acrylic and it works for them just great. So for me to sit here and go, well, no, this is the way or that is the way, I simply don't have that data. And I think both ways work just fine. I just tend to use the dual cure cement in my stuff. So once you have everything prepared, you kind of have to protect your surface area. And what I mean by that is that when you have your cylinders and you have your bar and you're going to be cementing one to the other after priming it, obviously, cement tends to go everywhere, in my opinion and in my experience. Let's put it that way. So probably not the opinion, but experience for sure. And I like to utilize a rubber dam because I'll just take it, I'll put it right on top. I'll take my marker and I'll just mark 4 dots and use little scissors to cut that area open. And now I have my protection sheet. So when I'm cementing stuff down, I don't have any issues with cement flowing down onto my model, maybe even getting caught between my analog and my titanium cylinder, ruining the interface. I really don't want to do that. And by simply utilizing that, or you can use cellophane, whatever you have at your disposal should probably work fairly well as long as you know how to use it properly. So once I have all those areas protected and I have my cylinders prepared, I will tighten my cylinders down, but not all the way down because I need to be able to fit my arch on top of those cylinders. So I tie them down about 3/4 of the way, and then I have my sheet, and then I'll put my cut down Q-tip handles right into those access holes, just like I did when I was sandblasting them. What that's going to do is when I'm applying all that cement all over the place, and usually get it very messy, it won't allow for the cement to flow into my access hole where my screw is. Okay, so that is prepared for that portion right there. What I need to do now is I need to prime my metal and I need to prime my bar. There are many different ways of doing that. There's like multi-primers, there's the metal primers, there's composite primers, there's million different primers, sorry. I like to utilize the GC multi-primer simply because it's one primer and it works on both things. It just makes it easier for me. I don't have to think about it. So I'll take some of that primer on just a micro brush and I'll prime both zones, the metal and the bar as well, the Trilor. Once that is done, I'll let it air out and I'll start applying my cement in those regions. I'll apply a little bit or a lot depending on how my pressure is on my hand at the time to the cylinder and some inside the bar, and I'll try to fit that on top of things. Sometimes it goes really smoothly, sometimes it's a nightmare because it kind of gets slippery or sticky or something happens and I don't line things up very well, but nevertheless I have enough working time to kind of get things lined up and put down. And if I have any kind of voids and anything else, I can just backfill with the cement as well. Now remember, our titanium cylinders are not tied in all the way, right? Because we wanted to make sure that the bar fits on top of things. So now that we have things lined up approximately how we want it, we're going to have to take out those little Q-tip handles that we've cut down to close those access holes. We're going to take those out, and we're going to screw our titanium cylinders all the way down to our analogs before the cement sets, hopefully. So once we have all that lined up, we're going to take the same driver we used to screw those things down, and we're going to use it as a spacer between the bar and the model, because the driver has the same diameter as a 2mm spacer, in my case at least. For you, double check things. If it's bigger, if it's smaller, just have something there so you can line things up as you need to go. Once everything's tied down, once everything is lined up, go ahead and take your light cure wand and activate the cement. Once the cement sets up, you take everything off, make sure you clean everything up, make sure you clean up all the excess cement, and also be very careful when you're doing all that cleaning up. Make sure you're not going to damage the interfaces of the bar, because that's where they're going to be connecting, in your case on the analogs of the model, but later on they're going to be connecting intraorally, and that's a very important connection not to mess up. Okay, once everything looks good, once everything's cleaned up, go ahead and try to fit it back on the model. Check and make sure that it's all nice and even, that it fits down evenly. Check with all the screws to make sure that everything ties down evenly as well. Once that is all done, you can go ahead and start setting up your teeth or whatever your plans are for that specific bar. That's pretty much it. That's all it takes to create one of these bars for either a temporary or permanent restoration. The concept is the same for both. It's just trying to follow all the steps to make sure you have the best possible restoration. Okay, folks, hopefully this has helped you some, and hopefully you guys will try to utilize this protocol. Obviously, if this doesn't work for you, please feel free to adjust it to the way that it's going to be usable in your practice. But all in all, good luck.